This is a homework problem you guys had on page 34, the CYU. I felt it important to have this as a review for you because it provides an example of a basic diagram without corresponding angles and all those transversal type problems where you do need to make a proof. Now I will take a paragraph proof where you write some explanations for me, but I'm going to make a 2-column proof because I want you to head that way. And as long as your sentences would say these same things, it would still be counted correct as of now. So one thing you need to make sure you do is actually read the problem. That's easier on a test or quiz, but make sure you do that in the homework. They tell us that we have 2 lines crossing at point C, and the measure of ECD is equal to angle D. So remember, when we name angles, this middle letter is important. That's where the angle's happening. So if I start at E and go to C and go to D, this would be the angle they're talking about when they give you that, and angle D is equal to it. So I'm going to mark both of those as equal, and there we have our given. So when it comes to a 2-column proof, we know our first statement is always the given. I'm going to abbreviate statement S and reason R. My first statement is that angle ECD is equal to angle D. And that is, of course, given. It was typed in the problem. It could be written on the diagram. As long as it's nothing you had to work for, it's given. Now, they ask, is ACB equal to angle D? Again, this is what they're asking. So if we're going to say yes, and we're making a proof, that'll, of course, be our final statement. But let's look at this diagram. A lot of you indicated on your homework that you noted the vertical angles, and that is basically half the battle of this proof. This angle here matches this angle here because they're vertical, and we know those types of angles. So we can say, if you see that, write that down. Anything you see in a picture is probably important to note. So we'll call that angle ACB, and it's equal to angle ECD. Now that wasn't given to you, although your brain probably jumped to that quickly. Of course you use the vertical angle theorem, and I'll abbreviate that by VAT. Finally, we don't have much more on this diagram. There's not much more we can use, so start trying to put what you've already said up here. It's really important you look back up at what you've already written to make your next statement. Proofs should have statements made based on things you've already said or things that are given. So if I go back and say, okay, well, angle ECD matches D, these 2 black ones match each other up there, and ACB matches ECD, the green ones match each other. If this black matches that black and this green matches that green, then pretty sure they're all going to be equal to each other. So we can say that this angle ACB actually matches this angle here because they all are equal to this center piece. That's their common friend, if you will. So we can say angle ACB is equal to angle D, and this is that reason where we might just have to guess sometimes, but I'll show you where you can see it, substitution. Okay, because if we see that ECD matches angle, every time I see ECD I'm going to have pink, and every time I see, I can replace those 2. Well, ACB is blue, and we'll make D red. Think of it in color. If pink is like red and blue is like pink, then the pinks really are each other. That's the same thing. So we can set these 2 equally to each other, and that's what we just did. That is substitution right there. And that's all they're asking you to prove. So we can say, we would answer this one, of course, yes, but we did that in our proof down here. Now finally, just to answer this, because a lot of you had some questions when you were working on your homework, is measure of A equal to angle D? When they ask that, they're asking, is it for sure? Like, does it have to be? Of course, you could probably come up with a drawing where they are. So I'm going to erase these colors for a minute. Just try some numbers. If you can prove to me a counterexample, that's one of the quickest ways to prove things are false. So if you could come up with a counterexample, it would be golden. So let's try a number. Let's say this is 50 degrees. Then this has to be 50 because we just proved that they're vertical angles. We also know that this has to be 50 because of our given. So 50, 50, 50. They're asking, does this have to be 50 up here? And by are they equal means does it have to be? Well, of course you could put a 50 in there and then they'd have similar triangles. But could you make it so it's not? We know this triangle here is committed to 180 degrees. So 50 and 50 is 100, therefore this is 80. Now up here, Do we have to make this 50 and that 80? No, I could make this 30, that's 80, and this would be 100 then. And we can definitely tell now, this right here is my proof of no. I made it so they're not equal, so they don't have to be equal.